Maybe you did this in physics class in high school. Here we have a sort of spongy rope, okay? And I'm just going to try to wiggle this a little bit. And until I find the right frequency, it's just kind of moving around. And then I get the right speed. Oh, look at that. And I build a standing wave. That is a powerful wave, okay? My hand is hardly moving, but the rope itself is going. You've experienced this with jump ropes and other things as well. All right, so now we found the frequency of this particular length rope. Dun, dun, dun. There's my speed. Now watch what happens when I double that speed. Okay? It's the Overtone series. When I double the speed, it would make this an octave higher. I would make the string in half. There will be a point exactly 1/2 the length of this rope here that will create a standing node. Let's watch what happens. Okay, I'm going to double my speed. Here I go. 1, 1, 2, 1, 2, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Okay, took a little while for it to establish, but you see what's happened? There's a spot in the middle there that is staying still, while 2 exact halves of my rope here are going back and forth. Okay, each of them, if this were sounding, would be an octave higher. All right, I can even do this into thirds. It's a little bit harder. Da, 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 da. I'm going to go with triplets. Da, 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 da. There we go. Now you see the thirds? There are 2 different nodes standing up. I'm trying to talk at the same time. Amazing, huh? Okay, well, if I were going some other pace, again, I would just have randomness on that string, but because I caught the frequency of that string, or some simple ratio of the frequency of that string, it created a unique sound. We discover this with guitars when we play harmonics on guitars quite often. You play the full length of the string and you hear the whole string sounding. In truth, it's vibrating in a lot of different ways as well, but the main thing that we hear is that string. If I just put my finger down on the node, that halfway point of the string, it'll be just like that jump rope or telephone chord that I was just doing. Hear how it's an octave higher? So what's happening is I'm making the string stop there. So I'm making the string do the same thing that that telephone chord was doing just a minute ago. Each half is vibrating. Okay? I could then, this point right here then, is exactly the halfway point on this string. All right? They happen to put a mark right there so you can find it quickly, but it's the halfway point in the string. It's an acoustical principle. A 2-to-1 ratio creates an octave. I could find the 1/3 mark. Again, they've been so kind as to mark that fret for me, but this is the 1/3 mark. So I would now do the same thing that I did before. As I hit this string, the 1/3 is vibrating, and this third and this third are also vibrating. Okay, it's not quite as clear as the, hear how that's the interval of a fifth? Because a 3-to-2 ratio creates a fifth. Now, if I could find it here, I could also touch the string on this third or this third, and amazingly it creates the same note. Likewise, I could do fourths. Fourths. That's an octave higher than 1/2, because now I've divided the string into 4. I could even go 5. Okay, so now do you notice the pitches that are sounding? There's E, B, E, G sharp. The harmonics create a major chord. And I can go the other way with that same thing. All right, this is what we call harmonics on a guitar, and we make use of those fairly often when we're playing. We play harmonics. You know, they work on a piano as well. Let me just demonstrate that for you. When I play this pitch, this low C, I think what I'm hearing is a low C. In truth, I'm hearing that note plus this note plus this one and all these others and a whole bunch of others along the way. I'm hearing those notes. Now, I know this is coming across on a video, so you might not hear those, but I want you to see if you can hear these other pitches sounding even as I play this one. I could hear that one fairly clearly. Try it again. I can hear all those chords. Now let me just demonstrate it a little bit more. I'm going to hold down some of these notes. I'm not sounding them, I'm just taking the dampers off of those strings. Remember the power of a standing wave. Sympathetic vibrations from this note will cause these to ring out. Watch this. Ah, so those pitches were all in this one right here. You say, wow, that's just, you know, vibrate. Well, let me try different pitches. I'll hold down these, which are not part of the Overtone series. I'm doing the exact same thing, and we'll see if they ring out. No, it just kind of dies, except really high pitches, because these aren't part of the Overtone series. Again, let me just do this, because this is kind of cool. Hear how much that rings out? And hear how this one doesn't. But if I hit a B down here, these are all part of the Overtone series of a B. Now they ring out. So, never underestimate the power of a standing wave. The standing wave is what causes us to create a major chord. That's what makes stable pitches out of 1, 5, and 3. All those overtones. The overtones are what make 1, 5, and 3 stable. And that's what makes these notes unstable and then resolve to stable. Right? It's kind of deep physics, but I hope that it will help you to remember that this is how all instruments are created. It's how all music works, more or less, and it's why we wound up with creating a major scale and creating a major tonic triad as being the most natural way to have stability at the end of our phrases.